One of the fastest ways to destroy a freshly built Turbo 400 is by installing the torque converter incorrectly. You may have heard that in order to fully seat the torque converter, you need to hear 2 distinctive click sounds. However, some sources say it's 3 clicks. Which is it? Well, to be honest, using this click method can be an easy way to get faked out when installing the torque converter, leading one to believe that the torque converter is fully installed when in fact it's not. And making this mistake will result in damage to the transmission within seconds of initial fire up. Hey, what's going on? My name's Robert and you are watching Southpaw Autoworks. This video is all about the installation of the torque converter into this GM Turbo 400 automatic transmission. There are a number of ways to verify proper converter installation, and each of the checks are quite simple and easy to perform once you know what to look for. Without further ado, let's get this show on the road. I think one of the greatest challenges for people installing torque converters is due to the fact that you can't see what's going on during converter installation. For starters, the typical torque converter is a sealed unit. It's welded closed at this joint. And to make matters worse, as soon as the converter is being installed, it's really hard to see what's going on the transmission end of things. In order to remove some of this mystery, we're going to take a look at an open torque converter. This one is out of a 4L60E, and I've also got the corresponding transmission parts for this quick demonstration. When installing the torque converter, there are several elements that need to spline to the transmission, not necessarily in this order, but for starters, these machine slots on the torque converter hub, the splines in the stator, and the splines in the turbine. Both the stator and the turbine float inside of the torque converter, and the fit between the splines is a tight tolerance, all of which make it more difficult to get those components splined to the transmission. Once again, not necessarily in any particular order, the torque converter hub slides into the pump. So, just to be clear, the hub comes through the pump body, rides on that pump bushing, but these machine slots engage with those drive tangs on this inner rotor, and that's what drives the pump at engine speed. The stator splines to the stator support. This stator is responsible for directing oil flow inside the torque converter, which has positive consequences. And the turbine splines to the input shaft. This is how we get power from the engine to the input shaft and ultimately down to the planetary gear set. Prior to installing the torque converter, it's a good idea to inspect the torque converter pilot. This is a machine surface and must not be beat up from mishandling. This torque converter pilot will engage the crankshaft pilot. The torque converter pilot must be able to move freely inside of the crankshaft pilot. With the flex plate installed on the crankshaft, the torque converter pilot should be able to be inserted 1/8 of an inch into the crankshaft pilot. Before we install the torque converter into the trans, we lube up the pump seal. We like to use high temp wheel bearing grease. It ensures that this seal has plenty of protection during initial fire up. We also lubricate the torque converter hub. This hub rides on the pump bushing, and that pump bushing was lubricated during transmission overhaul. Speaking of lube, it's also a good idea to prime the torque converter with automatic transmission fluid. I don't completely fill the torque converter because if it's completely filled with oil, as soon as I tip the converter on its side for the installation, all of the excess oil will start puking out of the torque converter. So I try to fill the converter to this level so I don't make a mess and waste oil. Another way to minimize oil spill is by tipping the bell housing end of the transmission downward. Now, this sort of thing is typically done with the transmission on a transmission jack and the trans securely tied to the trans jack so the trans doesn't fall off of the jack. So if the converter is looking a little crusty, that's because this one is. It's simply a converter core, just using it for demonstration purposes for this video. At any rate, we've got the converter primed with oil. The converter hub and the front pump seal have both been lubricated, so we're now ready to stab the converter. This bad boy tipped up on its side. Let's dab it. All right. And then it's just a matter of rotating and lifting until it starts dropping in. There, went a little bit. Now, I can get my fingers around the backside of the converter. So that's one sign that it's not in all the way, because when it is dropped in all the way, that will no longer be the case. You may hear some clicks as it drops, or in that case, a pretty solid thud. But I don't think it's in all the way yet. Looks like it's got a little more to go. Let me pull out on that. Push in. I pulled out just a little bit. I'm going to push in kind of hard. It's a nice thud sound, but it sounds kind of hollow to me, or tinny. Not as deep as it could be. So I'm going to keep going. I'll show you the difference. Now I can't get my fingers very far past even the edge of the converter before I run in to the inside of this bell housing. And now I think it's bottomed. Again, I'm going to pull the converter out just a little bit. Maybe. There it is, just a skosh. Oh, and I disengaged. There it goes. Let me do that again. Okay, I'm going to give it a nice push in. That's a nice deep thud. That sounds and feels really solid to me. That leads me to believe it's in all the way. Plus, I can't get my fingers around the backside of the torque converter. And to take some of the mystery out of this, the best way to check is by using a straight edge. And we're just going to take a measurement. So what I would do is I'm going to lay the straight edge right across this section of the bell housing on this face that mates with the engine block. And then I'm going to rotate the converter to line up one of these converter pads with this straight edge. And now it's just a matter of measuring the distance between the straight edge and the converter pad. And if all is right, then we should have at least 1 inch of clearance here. Once we've confirmed that we've got 1 inch of clearance, this transmission is now ready to be installed, but I want to share a little trick with you. You throw this trans on a trans jack, and if you do happen to need to dive bomb the trans one way or the other, if the converter end of that ends up getting face downward, it's possible that the converter can walk out a little ways. It might not fall out all the way, but it could move. But there is a quick and easy solution for that. Take some hardware, run that through the bell housing, take a standard old wrench here, or a metric, I don't care. Throw a washer on here and a nut. Run this guy down. I'm going to do is set that there. Well, maybe I'll get that over the pilot. I'll line that right up with the converter pilot. Seem to remember this worked better last time. At any rate, now I've got the wrench tightened against the bell housing and it's up against this converter pilot. And this thing should not fall out on you now. So, little pro tip for you. At this point in time, I've shared what it takes to install the torque converter into this GM Turbo 400. However, there is another clearance, but that clearance for the torque converter can only be checked with the transmission in a vehicle. But I don't have a vehicle handy to install this transmission into. So we're going to take a quick trip over to the greatest nation in the world, the imagination. So if you would, join me real quick as we pretend that we've got a vehicle on the lift, raised up. We've got this transmission on a transmission jack, and we've rolled that assembly under the vehicle. We've raised it up, and we're real close to the engine block. So now that we're within inches of the engine block, and I don't have to worry about this converter falling out, I will get this makeshift converter bracket removed. Just a bolt, a nut, and some washers, and of course a wrench of your choosing. Now that I've got the hold down bracket out of the way, I will be pushing this transmission up against the block until I can make full contact with it. I should be able to do this by hand, in other words, not using any bell housing bolts to try to draw the transmission up against the back of the block. So that may require me to angle the transmission this direction, of course change the height of the transmission, and angle the transmission this direction, because there are dowel pins in the back of the engine block, and they need to line up with their corresponding holes in the bell housing. So yeah, I may need to angle the trans this way to try to line up those dowel pins. At any rate, I can't stress this enough. This transmission should be able to be pushed flush against the back of the block without the assistance of the bell housing bolts. If I'm having to use the bell housing bolts to draw the transmission up against the block, then there's a problem. So once I've got the trans pushed all the way up against the back of the block, I'm going to be checking that to make sure that my converter rotates freely. Now it may be real close to the flex plate. It should be real close to the flex plate, but I should be able to rotate this converter freely. However, with the flex plate, this isn't the correct flex plate, but just bear with me. Be bolted to the back of the engine or the crank, and it would be real close to the converter like so. But it's not going to be touching the converter, or at least if it is, if the converter happened to be out a little ways, I should be able to push the converter away from the flex plate. Point is, there should be clearance between these mounting pads and the corresponding pad on the flex plate. We should be looking at anywhere from 1/8 of an inch of clearance all the way up to 3/16 of an inch of clearance, or 125 thousandths to 187 thousandths of an inch. How do you check that clearance? Well, you can use feeler blades if you have enough to stack that many. However, we like to use drill bits. You can find the appropriate size drill bit. Use a dial caliper to measure the thickness. If the drill bit's not labeled, throw the drill bit up there between the torque converter and the flex plate, and bam, you can quickly measure that clearance. So in a perfect world, we'll line that up and we've got, 1/8 of an inch of clearance, and we're good. Like I've already mentioned, it's possible that the clearance be too tight, and if that's the case, the converter may not be installed all the way, or there could be a problem on the engine side of things. Like, for example, the flex plate might be damaged, or it could be the incorrect flex plate for this application. It's just stuff to look at. On the flip side of things, so we went from clearance being too tight on this converter. It's also possible that the clearance is too loose. Now, this is, of course, checked before we run in the converter bolts. We want to check the clearance and make sure it's not too loose, because if it is too loose, once we run those converter bolts through the flex plate and into our converter, and we start to tighten those bolts down, once we've got all three in, we start to tighten them down, it's going to draw the converter out away from the transmission, and it's going to draw it right up against the flex plate, which it's supposed to do. However, if it's allowed to be drawn out too far because we've got too much clearance, what we've essentially done now is we're making less contact between those machined slots in the converter hub and the drive tangs on the pump. And as we get less and less contact between those two items that are lugged or splined together, we're increasing the chances of the torque converter hub failing or the inner pump gear failing, because we're putting a lot of stress on a lot less surface area. So we really want to keep as much contact between that machined slot in the converter hub and the inner pump gear tangs. So how do we do that? Well, if we've got too much clearance, an acceptable way to eat up some of that clearance or to tighten some of that clearance is to use a premium hardened flat washer that will live between this torque converter mounting pad and the corresponding surface on the flex plate. That'll eat up some of the clearance, so our pullout is not excessive and we maintain a good bite, if you will, between the torque converter and the pump. Before moving on, there are two things I want to clarify that I know I'm going to get questions about in the comments section, and there's one thing that I missed entirely. So let's go through those real quick. First clarification is regarding the bell housing. When the bell housing is brought up against the engine block and we get it fully engaged with the engine block, like I said, I'd be taking a look at the torque converter, and I want to make sure that the converter rotates freely. This tells me that the converter is not bound up, and I've got the green light to move to the next step. What's the next step? It would be installing each and every one of the bell housing bolts, getting them run down and torqued to spec. At that point, now I would want to check my converter clearance. Point is, I forgot to mention the bell housing bolts, and if the bolts are not installed and tightened all the way down, the transmission may start to walk away from the engine block while I'm monkeying around with the converter clearance. If I don't notice, it's just going to create some unneeded headaches. At any rate, clarification number 2 is regarding the torque converter clearance. So once I'm happy with the clearance, I will install all 3 of the torque converter bolts, which is going to draw the converter up against my flex plate here. But people get confused here. They say, wait a minute, what do you mean? I had to set a clearance. The converter needs to be able to move, and I had to dial in that air gap or that converter clearance, and now I'm going to tighten the bolts down and the clearance is going to go away? So I've seen this online. I wanted to address this real quick. That's normal. Once the converter is drawn up against the flex plate, the bolts are tightened down. As the name implies, the flex plate is supposed to flex. So that will essentially allow the converter to move ever so slightly back and forth during normal operation. So again, we're going to have a clearance to begin with. We need to dial it in. Once I'm happy with it, I run the bolts down, the clearance goes away. That's normal. The omission, moving on to the omission. The flex plate, once again, there is a clearance between the flex plate and the back of the engine block. At least there should be. That clearance should be right around 3/4 of an inch or 750 thousandths of an inch. How you measure that is take one of those where the converter bolts feed through the flex plate, line one of those holes up with a machine surface on the back side of the engine block, and then use a dial caliper. They've got a depth rod. You can feed it right through the hole in the flex plate, rest it right up against the machine surface, grab that reading, and then we've got to do a little math here. We got to figure out the thickness of the flex plate, whatever that is, and deduct it from our overall reading, and that will give us our flex plate to engine block clearance. If the clearance is not correct for some reason, then I'd be looking at maybe there's damage to the flex plate. Maybe it's installed backwards, or maybe it's the wrong flex plate for this application. I don't know, but just something to be aware of. This show is a ton of hours to produce, and we could use your support. You can learn more by checking out the video description down below. Speaking of that video description, there are a number of good things going on down there. For example, the Turbo 400 build series. You can find links to each and every one of those episodes down there. Turbo 400 resources. You can find product links for Turbo 400 parts, tools, and supplies. Once again, lots of good stuff going on in the video description down below. Switching gears, we are far from done with the Turbo 400. While we have done the build series and we're now doing this short series that's here to elevate or support that build series, we're still not done with this mini series. Up next, we're going to be covering topics such as Turbo 400 fluid capacities, how to check the fluid level when the trans is in the vehicle, as well as a number of drivability issues that may arise after the new transmission has been installed in the vehicle. So we'll be covering potential problems and, of course, some solutions for those problems. Point is, we've got a lot more in store for you. If you're new here to the channel and you haven't done so already, be sure to subscribe and hit that notification bell too, so you don't miss out on any upcoming videos. Once again, my name's Robert, and I will see you next time.